So I want to recap the information we went through on Monday's Zoom session about similar polygons. So as a reminder, we talked about ratios, which is just another word for a fraction. When we set two fractions equal to each other, we create a proportion, and we can use the cross products property to solve a proportion. The reason we want to know how to solve a proportion is because when we're dealing with similar polygons, our side lengths will be proportional rather than congruent. Our angles will still be congruent, but our side lengths will be proportional. And so we learned some new vocabulary. We learned that the similarity statement tells you how everything matches up. We learned that when you make the fractions out of all the sides, you create a statement of proportionality. And when you actually plug the numbers in and reduce those fractions, you create what's called the scale factor. So in example 2, we looked at a similarity statement, showed which angle matches up to which angle, wrote the statement of proportionality, and then figured out what that scale factor was. And you'll be asked to do those things in the homework for this section. All right, some other things that we can do are we can determine if polygons are similar. So in example 3, that's exactly what they're asking us to do. You're supposed to look at those two quadrilaterals and decide if they're similar. Then, if they are similar, they asked us to write the similarity statement and to find the scale factor of the smaller polygon to the larger polygon. So first, let's determine if they're similar. Remember, similar has two conditions. The first is, can you find a matchup on the angles for each angle in the first figure and match it up to an angle in the second figure? So we can see that all the angles have been marked. And so the angle F has exactly the same marking as angle Z. They both have single arc marks, so that means they're congruent. So I see that we have one set of angles that is congruent. If we keep going, I can also see that angle G has the same, well, let's go to H first. Angle H has a double marking, and so does X. So I know that angle H is congruent to angle X. The triple markings are on the G and the Y, so I know they match up. So they're trying to tell me with the markings that angle G is congruent to angle Y. And then finally, if we look at angle J has a right angle mark, and so does W. So obviously they're the same measure. So we can say angle J is congruent to angle W. So we have that first condition happening. We have that the angles are actually congruent to each other in those two quadrilaterals. The second condition that has to happen, and again, I'm getting this from the box right here that says we have two conditions for similar polygons. Corresponding angles need to be congruent, and corresponding side lengths need to be proportional. So let's check that second condition. Now, when you're checking the conditions and you don't have a similarity statement to work with, what you're going to do is look for the smallest number and put it over the smallest number in the second shape. So in this first shape, the smallest number is a 12. So 12 over, what's the smallest side in the second shape, is a 15. So if you put smallest number over smallest number and then reduce, top and bottom divided by 3 will reduce down to 4 over 5. You've got to do that with all the sides, though. You've got to make fractions out of all the sides and see if they reduce down to the same number. So let's just go in numerical order. The next biggest number is a 16. If we put that over the next biggest number in the next shape, it's going to be over a 20. If you divide top and bottom by 4, you are again going to get 4/5. If we do it with the 20 in the first shape, and the 25 in the second shape, so we'll have 20 over 25. Divide top and bottom by 5 this time, and you get 4/5. And then finally, we have a 24 in the first shape and a 30 in the second shape. So if we put 24 over 30 and divide top and bottom by 6, we get 4/5. So if we make a fraction out of all of the sides and we go in numerical order, you do get those fractions to all reduce down to the same number. So both conditions have happened. We have proportional sides, we have congruent angles. And so yes, these two shapes are similar. So we're going to have to write the similarity statement since they are similar. And so let me erase everything I've put on this shape so it's a little less messy. When we write our own similarity statement, we do it the exact same way we would have done a congruent statement. You can pick any order you want for the first shape. And so for the first shape, I usually just like to go in alphabetical order. So F, G, H, J. Remember, we're using a similar symbol, not a congruent symbol, because they're not the same size. And we're going to travel the markings the same way. So if I went from F to G to H to J, I went from the single marking to the triple to the double and to the right angle. So I have to travel the same way. I'm going to go from the single marking to the triple to the double to the right angle. And so the correct matchup on the letters would be F, G, H, J is similar to Z, Y, X, W. And that is what's called our similarity statement. It shows you how everything matches up. And then it asks you to find the scale factor of the smaller to the larger. And that just means the smaller number goes on top and the larger number goes on the bottom. And we've already done that, right? 4/5 is the scale factor. So 4/5 is what all of the sides reduce down to when you make fractions out of them. So our scale factor is 4/5. Right? So in that case, we didn't know if the polygons were similar, so we had to perform the two tests. Test for the angles being congruent and for the sides being proportional. All right, example 4 is asking us to solve for missing sides. So notice it says solve for or find the value of x. So when we're finding the value of x, and I guess there's not really an x here, there's a question mark. So remember, we'll change those to x's. So anytime you see a question mark, think of it as an x, okay? So in the first example, example 4a, if we have to find that x, I usually start with the x. LM is what the x is on, right? L and M, let's number these. 1, 2, 3, 1, 2, 3. L and M are in the second and third position, and so are Q and R. So LM should go over QR. So that means we would put x over, and if you go to the picture and find QR, it's right here, x over 15. Now, what else can we do? Let's see, we've got to finish off the proportion. So on the other side, let's go back to the original triangle. Always do that when you're going to write your proportion. Go back to the triangle you started with. And so the only number I see is on KL, right? KL is an 8. So I'm going to put 8 over something. Well, K and L are in the first two positions, and so the first two positions on the other side are PQ. So if we put 8 over PQ, which is 20. All right, if we cross multiply, we can solve this thing. We're going to do 8 times 15 and x times 20, which is going to give us 20x equals 120. If we divide by x, our x will equal 6. So we have just solved for a missing side by setting up a proportion and solving it because we know that similar shapes have proportional sides. Let's try it again. In example 4b, the x is on dt, right? And so we really don't have to write this statement right here that I just highlighted in yellow in the first problem. We really can just fill in the numbers as we go. You don't have to write that statement. So let's try it that way this time. So if we, again, number these positions, dt is my x. That is in the first two positions. And so we get to put that over tu. So tu in the dt and tu. Tu we don't, oh, tu, I'm sorry. Tu is 60. For a minute, I thought we didn't know it. So tu is 60. Let's set that equal to, well, we got to go back to where we started. We started with the smaller triangle, and the only other number I see is 21. 21 is labeling CT. That's the first and third position. The first and third position on the other one's TV, and that is 70 in our picture. So x belongs over 60 and 21 belongs over 70. All right? If we cross multiply, we are going to get 70x equals, and I wish I would have done this ahead of time. Let's see, 0, 6, 1,260. If we divide by 70, we're going to get x equals, oh my, I wish I would have done this ahead of time. Hold on. Let me go to my calculator here. 1260 divided by, whoa, close. No, divided by 70 equals 18. So our x would equal 18 in this case. All right, so again, if you are solving for missing sides, you are setting up a proportion and solving it. Just make sure you get the matchup correctly, right? There's a specific way you got to put the proportion together. You have to watch the order of the letters. That's why I keep labeling them with a 1, 2, 3. All right, the last two examples, we just put some algebra, even though all of it's algebra, but we put some algebraic expressions on one of our sides. So you'll notice in example C, we have a 2x minus 3 on one of our sides rather than just a question mark. And so that's, again, where I always like to start. When I start building my proportion, I look for the variable. So I'm going to start with the 2x minus 3. And if I number these letters, the 2x minus 3 is labeling CB, which is in the first two positions, so that should be put over NM. If you look down below, NM is 49. The only other number in the first triangle, again, you always go back to the first triangle when you go to the other side of the proportion, is a 13. And 13 is CD, which is the second two positions, and so is ML. And ML is 91. If we cross multiply, we'll have 91 times 2x minus 3 equals 13 times 49. Oh boy, I really wish I would have done these ahead of time. 13 times 49 is going to give us 637. Now you can distribute or you can divide by 91. I think most of you would distribute, so that's what I'll do. 91 times 2 gives us 182x. Minus 91 times 3 gives us 273. That equals 637. If we add 273 to both sides, I'm kind of glad these numbers are getting big because I want to talk about another way you could do this. So we get 182x equals, let's see, 10, 11, 910. If we divide by 182, our x, I believe, would be 5. Yep, it would be 5. So in this case, our x equals 5. All right. So you could certainly keep the numbers big like that. That's definitely okay. But I don't know if anybody would have known that if you look at 13 over 91, that can actually be reduced. The top and bottom can both be divided by 13. So if you're dealing with large numbers and one of the fractions can be reduced, you could do that. If we divide top by 13, we get 1. If you divide the bottom by 13, you get 7. So it would have been okay to do your cross multiplication with the 1/7 instead of with the 13 over 91. And at least then you'd be dealing with smaller numbers. So let's change colors here and actually do that. If I took 7 times 2x minus 3, so I'm going to be dealing with this cross multiplication instead. And then 49 times 1 equals 49. Distribute, you get 14x minus 21 equals 49. If we add 21 to both sides, we get 14x equals 70. And if you divide by 14, you still get x equals 5. So anytime you're dealing with fractions, if they could be reduced and you want to work with smaller numbers, that's mathematically correct. You can do that. All right, the last one. Same thing, what we've been doing. We're going to make a proportion because we're dealing with sides. And so I like to start with the x. The x is right here, 11x, right? So we're going to start with 11x. That is on line segment GE. GE are in the first and third position, so go to the other side and look for GC. GC is down right here, right? 24. So 11x belongs over the 24. Go back up to the triangle you started with. You started with the bigger one on top. So we have 77, which is FG. That's the first and second. So that belongs over GB, which is 21. So this is definitely a case. Let's try this. Let's reduce that second fraction. We could rewrite this as 11x over 24 equals. You can divide both these by 7. So you'd get 11 over 3 instead of 77 over 21. And at least the numbers are smaller. Now you guys have calculators, so if you rather keep the numbers big, it's certainly fine. but you could also make them a little bit smaller if you wanted. So if we do our cross multiplying, we get 11x times 3, which is 33x, equals 24 times 11, which is 264. If we divide both sides by 33, we're going to get x equals 8. Okay, so definitely you could have kept the bigger numbers and you still would have gotten x equals 8. But the moral of the story in the rest of these problems is anytime you're dealing with solving for missing sides, you must set up a proportion and solve using cross products property.